Okay, welcome. Thank you so much, everybody, for attending. It's nice to see people. I'm Meredith Weber. I'm here in sunny Philadelphia. And I'm so happy to welcome you today to this session for this afternoon. I apologize, there's some virtual school noise going on in the background. And it's kind of ironic because there is some math anxiety going on as we speak in the next room. So this is a topic where I think all of us could really use some support. We're going to be hearing about predicting academic achievement for students with learning disabilities, with academic enablers and academic self-concept today. We are fortunate enough to be joined by Lily Russell and Dr. Cristin Hall of Penn State University. Thank you so much. Please leave your microphones on mute for the session. And if you have questions, please write the questions into the chat box and they'll be addressed during the session. We'll also leave some time at the end for people to ask questions. Thank you.
Yep, and I'll be moderating that chat throughout. So, you know, if you think of questions as you go, we can certainly try to squeeze those in as we move along too. So Lily, did you want to start us off quick or?
Yeah, I was just gonna basically do introductions, but
we've sort of done those. And you're the one who's controlling PowerPoint slides, right?
Yep. So yeah, so I'm just gonna hand it off to you to introduce us to our background and literature.
Great. As
yeah.
Mary shared with us, my name's Cristin Hall. I'm an assistant professor at Penn State University, and Lily is my advisee. She's one of my graduate students, and she was really the lead on this project. This was her master's level project, and I'm really pleased to see the results, and I think you will be too. So you all may have heard of the idea of academic enablers and how they might relate to academic achievement. So according to DiPerna and Elliott, sorry, I said elephant. I'm not sure how that happened. My apologies. They define academic enablers as attitudes and behaviors that allow a student to benefit from classroom instruction. So those are all those things that we don't measure super well unless we're concerned about them, but they certainly are of interest. So motivation, study skills, interpersonal skills, how engaged students are. Early work by Jim DiPerna and his colleagues showed us models of the contribution of these academic enablers and achievement in both reading and math. So we know that they do make a difference. And then a little bit later on, some other research by Jenkins and Demaray, I hope I'm not mispronouncing that person's last name, also found that academic enablers accounted for about 11% of the variance in students' reading performance on a standardized test. So it does seem to pack something of a punch. Next slide, Lily. Okay, how about for our students with disabilities? That's sort of the next question, and sort of asking ourselves whether or not these constructs kind of interact in the same way for our kiddos that may have some learning needs or learning differences. Students with specific learning disability had lower self-ratings and teacher ratings of academic enablers than their peers who were in the general education setting. So it does seem like there's a little bit of a difference. And that when controlling for past academic achievement, academic enablers do promote academic achievement for students who are identified as having ADHD. So again, they seem to make a difference for our kiddos with disabilities. Did you want to click? Oh, thank you. But what about academic self-concept, right? So when we have kiddos that are having issues with learning, they're not having an easy time of it, how they think of themselves as learners and how they engage in the learning environment. Curious about how these things also have an impact given the fact that they're already having issues with their academic skills. And now how are these other things helping or not, as the case may be for these kids. Self-concept, as defined by Gresham in 1995, is a complex interactive network of person holds about his or her confidence in enacting certain behaviors and in having certain culturally valued personal attributes. It's a huge mouthful, but I think for the purposes of our work, it's a pretty good place to start in terms of thinking through how people are thinking about their own capacity to engage in academic work, and their capacity to remain engaged and so forth in their academic work. There's been a lot of research in this area, including research on multiple sets of data that shows that both reading and math self-concept in middle childhood seem to have a significant impact on later reading and math achievement. So how our students are thinking about themselves in this space is also having an impact on their actual academic performance. So it's not only about our concern about how they think and feel about themselves in the academic space, but it also seems to be having an impact on their academic. And other work that shows that a positive sense of academic self-concept was the best predictor of student grade point average. So that's some interesting work there as well. So we have reason to think that these are concepts that we might be interested in. There was a large meta-analysis in 2002 that showed a significant mean effect size difference for academic self-concept for students with specific learning disabilities. So it seems like when we look at this across multiple research projects, it seems to hold, and that there seems to be kind of a like a bidirectional reciprocal effect between academic self-concept and academic achievement that we've seen in elementary school students within the SEALS data set, which we'll hear more about the SEALS data set when Lily kind of gets into the specifics of the study.
Thanks so much for going over the background and all of that research. So now that we've had a chance to review the background literature in this area, I'd like to talk a little bit about the study that I conducted. So the goals of the study were twofold. Firstly, I wanted to examine the possibility that academic enablers predicted current and future academic achievement for students with specific learning disabilities. And secondly, I wanted to explore the possibility that academic self-concept may function as an academic enabler for students with specific learning disabilities. Those goals led me to 2 questions and a few hypotheses. The first question addressed the goal of investigating whether academic enablers would predict both current and future achievement for students with SLD, and I predicted that they would. And the second question addressed the second goal of examining whether academic self-concept would function as an academic enabler. And again, I predicted that it would. So now I want to get a little bit deeper into the methods that I used to carry out my study. So I performed a secondary data analysis of the special education elementary longitudinal study, or SEALS dataset, which I used as my data source. The SEALS study was funded by the Office of Special Education Programs, and it was conducted by the research firm SRI International. So I've provided the original data collection dates here, and you can see that it was conducted a little while ago, and I'll come back to that later. So in this next section, I want to give a brief overview of the data collection procedures and the measures used in my study. The SEALS study collected a lot of information from many different sources, including parent interviews, teacher questionnaires, student direct assessment, and even a lot of other sources as well. However, for my study, I chose to use only 2 of those data sources. The first was the teacher questionnaire described here. So it was filled out by each student's primary language arts teacher. It included questions about things like student behavior, classroom expectations, and the accommodations and modifications provided to each student. There were a group of 24 items in the questionnaire that asked specifically about student behavior. Some of those items came from the social skills rating system teacher form, so the SSRST, and there were other items that were created by the SEALS team to be similar to those SSRST items. The other data source that I utilized was the student direct assessment. So in order for students to participate in the direct assessment, they surveyed teachers to screen to ensure that they would be able to. And then they had an alternate assessment procedure that was available for students who were not able to participate. And then school psychologists and others trained in assessment administered a number of tests, including subtests from the Woodcock-Johnson 3 research edition, a brief version of the student self-concept scale, and the school attitude measure, as well as others. So now I want to just give you a brief overview of the details of each of the measures that I used to measure the variables in my study. I could not get that word out. So the first of the academic enabler composites that I created was study skills, and it was measured by a 3-item composite collected from teacher report data gathered during wave 2. These items came from the 24 SSRST items that I mentioned earlier, and they were rated on a 3-point Likert scale. The internal consistency for the composite was measured at 0.79. And some sample items for the composite are that the student completes their homework on time, or that they do things on their own, even if they're hard. Engagement was measured with a 6-item composite collected from teacher report data, again, gathered during wave 2. These items also came from the 24 SSRST items mentioned earlier, and they were rated on the same 3-point Likert scale. Internal consistency for the composite was measured at 0.74, and some sample items from this composite were that the student joins group activities without being told, or that the student follows directions. Interpersonal skills was measured with an 11-item composite collected from the same teacher report data, also collected during wave 2. The items, again, came from the same 24 SSRST items, and they were rated on the same 3-point Likert scale. The internal consistency for this composite was measured at 0.84. Some sample items for this composite were that the student makes friends easily or cooperates with peers without prompting. Motivation was measured with a 7-item composite collected from student self-report data, and it was also gathered during wave 2. These items came from the school attitude measure, and they were rated on a 4-item Likert scale. Internal consistency for this composite was measured at 0.82, and sample items from this composite are the students rated themselves as going to school is not boring for me, or school will help me have a better life. Academic self-concept was measured with a 5-item composite collected from student self-report data, again, and also gathered during wave 2. These items came from the student self-concept scale and were rated on a 3-point Likert scale. Internal consistency for the composite was reported at 0.73 as measured by, or as reported by Way and Martyr in 2012. Some sample items for this composite were I can follow classroom rules and I can do my homework on time. The final variable in the study was math achievement. In order to measure math achievement, I created a math composite using W scores from 2 subtests on the WJ3 Achievement Research Edition. The composites were created by calculating the arithmetic mean of the 2 subtests in the composite. This is the same process that the WJ uses to calculate cluster W scores. And composites were created for all 3 time points, as you can see here, in order to create the control variable of past math achievement, current, and the outcome variables of current math achievement and future math achievement. W scores, standard scores, and percentile ranks were included in the data set for each of the WJ achievement tests. W scores were chosen for use in this study because out of those 3, they were the most sensitive to change. So now that I've briefly reviewed the measures that I utilized, I want to give you an overview of my selection criteria and the sample that it resulted in. So I know this doesn't look like a flow chart yet, but stick with me. It will be a very pretty flow chart in just a few minutes. So the full SEALS sample includes several thousand students across all disability categories. But since I had already decided and already identified that I was interested in students with SLD, my pool of students was about 958 cases. I then applied a number of exclusion criteria, as you can see listed here, which resulted in overall about 795 cases from the subsample of students with SLD that were identified as unusable. Mostly that was due to teacher non-response in wave 2, which resulted in not being able to calculate those composites that I just talked about, or student non-participation in a wave of data collection, which resulted in not being able to have that achievement data, which I had mentioned. So after I figured this out, I also looked at the data and had to remove 8 outlier cases. And then I went back and looked to see if there were any cases where I could impute the data, which basically means that I looked to see if there were places where there was only a few items missing. And so it's actually similar to when you have an omitted item on like a BASC. And so I went back and basically used the mean from each of these composites to substitute for the 1 or 2 missing items. And that was on 29 cases, which is to illustrate that kind of the point that I was making earlier, that so many of the cases that I lost were because teachers didn't respond or students didn't participate, not because there was only 1 or 2 items missing. So then I was still trying to get a bigger sample. And so I realized that this is actually only a part of my results, and my full results looked at both reading and math. So since I was basically running 4 separate analyses, there were some cases where I could include students who may not have had all 4, data for all 4 analyses, but maybe they did for just 2. So I was able to include an additional 39 cases when I looked at it that way. So I figured that it might be helpful to kind of visualize this. So I began with 958 potential cases. And then when I had to subtract the 795 unusable cases that I had identified from the exclusion criteria, I ended up with 163 possible cases. From there, I had to exclude 8 additional outlier cases, which brought my possible cases to 155. At that point, that was when I was able to use those imputed cases, which brought my sample up to 184 cases. From there, I was able to add in the selectively usable cases, as I called them, which brought my final sample to a total of 223 cases. And because I included those selectively usable cases, I made sure to label the total number of cases that were included in each analysis at the top of each of my tables, just to be really explicit about the number of cases that were included in each analysis. So now that we've talked about how I got to the sample that I did, I want to provide you with a little bit of a description of what that sample looked like. So here you can see the distribution of the demographic variables of age and grade within the sample. And all of the participant characteristics that I'll be talking about in the sample description were measured at wave 2, because that's the time point that I considered current in my study. Since all of it is in the past, it's a little bit arbitrary, but that's the way that I conceptualized it in my study. So that's how we are going with it. One interesting thing that I did want to point out here is that I used the same colors on this slide for like the youngest in both groups is this teal, and then on up. So I think it's interesting that there's some different distribution patterns, which I do think hints a little bit that there may be some students who were potentially held back at different points. So I think that that is something to be aware of within the sample. Continuing on with the sample distribution, you can see the demographic variables of family income level and urbanicity here. Sorry, I'm pointing on my screen and you're not seeing it. Here, you can see family income level and urbanicity and their distributions. There were 4 cases in the that did not include information for family income level. So I have that listed here as well. And then I also have the distributions for race, ethnicity, and sex. So now that we've reviewed a little bit about the sample, let's take some time to talk about the method of analysis. So I used hierarchical multiple regression as my chosen method of analysis because it allowed me to add my variables in a systematic way and to examine the contribution of specific variables at predetermined stages. All assumptions for HMR, including the assumption of multicollinearity. Well, I guess it's really the assumption of not multicollinearity, but anyway, as well as independence of residuals and others, were checked and found to be within acceptable limitations. If anyone has any questions about that, I'm happy to answer them, but it's not very interesting. So because I had two dependent variables, the current and future math achievement, I ran two regressions sequentially using the same blocks of variables, which I will describe on the next slide. It sounded like someone unmuted. Did someone have a question? Okay, keep going. Okay, so for the initial analyses that I had alluded to earlier with my goals and hypotheses, the independent variables were entered in the following order. Past math achievement was entered in block 1, then all 4 academic enabler composites were entered in block 2, and then academic self-concept was entered in block 3. I ended up with some unexpected findings, which prompted additional exploratory analyses. So the independent variables for those analyses were entered in the following order, which was the academic enabler composites were entered in block 1 and academic self-concept in block 2. So as I think I mentioned earlier, as Chrissy actually mentioned earlier, this was my master's level project. And one of the steps that I took to prepare for my defense meeting was to run some additional analyses just in case questions came up. And I wanted to consider the possible effects of demographic variables. So the demographic variables, so the variable ordering for this additional analysis was previous math achievement, demographic variables, academic enablers, and then academic self-concept. The demographic variables that I entered were race, ethnicity, sex, wave 2 grade level, family income level, and urbanicity. I want to pause here for a moment to point out that in the visuals that I've just walked through, the colors were specifically assigned to the blocks of variables, and the color assignments will continue into the results section. So briefly, just to provide clarity, the lime green is for the previous math achievement. The orange is for demographics. Teal is for the academic enablers, and blue is for self-concept. And then also, in addition to utilizing the colors from the previous visuals to specify the variables and the blocks, I've also highlighted the relevant results in each of the tables. I've highlighted significant results in green and non-significant results in red. The initial results showed that the control variable of previous math achievement was a significant predictor of current and future math achievement for students with SLD. When controlling for previous achievement, the addition of the academic enabler composites and academic self-concept to each regression did not result in the contribution of any significant amount of additional explained variance. Despite the lack of significant change statistics, the overall F for all 3 blocks of each of the initial regressions was still significant. This was due to the strength of the relationship between the control and outcome variables, the previous math and then current or future math achievement, So the fact that there's a strong relationship between math achievement scores over time isn't really a surprise. I guess it's nice to have confirmation, but like, it's not really a surprise. What was surprising to me in the context of this study and the existing literature was the second bullet point. The fact that none of these other factors accounted for any additional significant explained variance in current or future math achievement. So to say that another way, the fact that over time, students with SLD who had higher levels of motivation and more measured study skills didn't begin to outperform their peers who had lower motivation and fewer measured study skills. I found that surprising. So due to that surprising finding, I felt that it would be appropriate to perform additional analyses without the previous math achievement control. I felt like this would be valuable, not only because of the unexpected outcome of these initial results, but I also wanted to ensure that my results could be compared to results from existing literature that had not been able to control for prior achievement. So in this second round of analyses, the additional, these additional analyses show that without controlling for previous math achievement, academic enablers account for a small but significant amount of the variance in current and future math. As we saw in the previous round of analyses, the overall F remained significant for the second block in all 4 regressions. For most of the analyses, the pattern was similar to the previous analyses with a significant overall model, but no significant change statistics, indicating that academic self-concept had not added a significant amount of additional variance to the current or future reading or, I'm sorry, I did not change that. I will start that sentence again. For most of these analyses, the pattern was similar to the previous analyses with a significant overall model, but no significant change statistics, indicating that academic self-concept had not added a significant amount of variance to the future math regressions. This was not the case for current math. The addition of academic self-concept resulted in a significant F change in the current math regression, which increased the amount of variance explained by the model by 2.1%, increasing the total explained variance from 10.1%, 10.4% to 12.5%. When academic enablers were held constant, motivation and academic self-concept were significant predictors of current math, and study skills and motivation were significant predictors of future math. There was a significant F change for future math with the addition of the demographic control block, but not for current math. So, sorry, I forgot to introduce that we are stepping into my round 3 analyses and the addition of the demographic control block, which, as I said, added a significant F change for future math, but not for current math. Which means that when previous wave 1 math achievement demographic variables and academic enablers were held constant, previous math achievement and wave 2 grade level were significant predictors for the current math model. And previous math achievement, wave 2 grade level, and family income level were significant predictors for the future math model. So I think it's important to address some limitations. Any study has limitations, and this study is no exception. Many of the limitations of this study are related to the fact that it is a secondary analysis of extant data. As we saw in the flowchart earlier, a great number of cases were excluded due to missing data. In most cases, as I mentioned, this was due to teacher non-response to the questionnaire or student non-participation in the direct assessment. And I'm sure many of you have experienced teacher non-response before. So I think it's understandable how that could happen, but it definitely is a factor to that needs to be acknowledged. Sorry. Additionally, the dataset did not include the information that would have allowed me to disaggregate or separate the cases by SLD subtype. So the effects that I'm studying could have been blurred by some of, so that could have blurred the effects of some of the variables in the model, because you might expect there to be a different role for academic enablers and academic self-concept in the larger study in reading achievement versus math achievement for a student who had an SLD in reading fluency versus math computation. And additionally, you might also expect a student with an SLD in oral or written expression to have a different trajectory in math achievement versus a student with an SLD in, say, math computation. So I think that that is certainly a factor that, as I said, may have blurred some of these effects. As I alluded to earlier, it's been over 20 years since the data collection for the SEAL study began. In the intervening time, the IDEA was reauthorized in 2004, which allowed for the utilization of the RTI method of identification of students with SLD, excuse me, rather than the discrepancy model, which was the only method that was allowed at the time of data collection, which I think is an important distinction. Additionally, the technology that was available at the time, or rather, technology was much less accessible to students and districts, and it was very different from what we think of today. To add some perspective, in 2000, when data collection started, Google was not yet a verb or a household name. Gmail didn't exist yet. Windows XP would not come out until the following year, and the first iPhone would not come out for another 7 years. So it's important to note that many of the technology-based accommodations and interventions, and even diagnostic tools, really, that are commonplace today either didn't exist then or were not feasible for many students or districts at that time. So I think that's an important caveat as well. However, this is the only publicly available data set that disaggregates by disability status. So while it certainly has its limitations, this study would not have been possible without it. So with those caveats in mind, I do want to discuss the implications of the research. And I think, at least in my opinion, the most significant implication from these findings is that among the tested variables, previous math achievement is the strongest predictor of current and future math achievement for students with SLD. Now, don't laugh at me, because I know you're thinking, well, duh. And I know that that sounds simple, but I think we often think about some of these other variables that I tested as being important in the equation. And I think that they are. But my findings show that they aren't always, they may not always be as important as we think that they are. Which, to be honest, as a researcher, kind of makes me a little sad, but that's okay. And I think it's important, just as a little sidebar, like I think it's important to share the results even when they don't go the way that you want them to. But anyway, back to what I was supposed to say. I think that the results really show that previous achievement is your best predictor of those that I tested. And I think that really that's what we want to hear, because previous achievement is something we can change. It's hard, it takes work, you know, but I think that has implications for early intervention and for intervention selection. So anyway, this doesn't necessarily mean that we should ignore academic enablers or try to choose interventions that would hinder the development of academic enablers. But I think we should ensure that we are prioritizing the development of math skills for students who are identified because of their struggle with math skills. That said, there may be times when you may want to consider academic enabler type factors such as engagement and motivation when choosing an intervention. If, for example, you were choosing between two well-researched, validated math programs for a student who's not demonstrating motivation in the classroom, and one of the programs has been shown to improve motivation, then that's probably the program you want to go with. However, sometimes I get concerned, and I think that sometimes teachers get confused when we start thinking about prioritizing academic engagement or academic enablers and other factors similar to that over prioritizing strong academic interventions. So as an example, if a teacher were working with students on their math facts and in an effort to preserve their academic self-concept and motivation, this teacher tells the students, "That was a good try, keep up the effort," each time they answer, without offering corrective feedback when they provide a wrong answer, then I would be concerned, because that feedback is not helping the student learn the correct answer to the math fact that they missed. So I know that that might seem a little silly, but I hope that it illustrates the point that I'm trying to make. Another example that I wanted to offer, particularly regarding older students, is sometimes I feel that we prioritize the interpersonal dynamics of group work over the actual academic content that we're trying to teach. Now, you may hear some of my feelings toward group work here, but bear with me. So I think that if our goal was really to develop students' interpersonal skills for group work, we would try to do a better job of creating opportunities for group work throughout their academic journey in order to scaffold that experience, not just throw these students into it in middle school or junior high. And we would provide them with resources in the classroom and through their teacher to build those interpersonal competencies, not just expect them to magically know how to divide up the work and do a group project. And if the goal was truly to build interpersonal skills, then group projects would not be worth so much of the grade. If it's just an interpersonal growth exercise, why is it worth 15% of the grade? So anyway, as I said, perhaps I'm coloring that a little bit through my own experiences. But I think it helps to illustrate the point that I'm making here, that I think sometimes this can get a little lopsided. Does anyone else have some examples that you've seen where teachers or administrators have prioritized academic enablers or other like non-cognitive skills over core academic skills?
I did see something in the chat from Mary, actually, a question about, do you think that peer tutoring or peer coaching interventions tend to be good or less good in terms of motivation or interpersonal skills? And I think, Mary, thank you for the question. I think that that kind of speaks to what you were hoping to talk about here, Lily, around this idea of like, I think we know as practitioners anecdotally, in particular at the secondary level, you'll get that teacher who said, this kid just isn't motivated, or this kid is lazy, and whatever. And there's this narrative about trying and about encouraging trying behavior and so forth. And, I think all of us would agree that it's not that we don't care to help kids to feel more motivated at school. And, we certainly would want to encourage anything that helps kids to find the work less painful, quite frankly, in particular in cases where the work has already been hard. But when it's at the expense of actually intervening with the skill itself, it's like with that. But to Mary's question though, I don't know, I think it would just depend. I think there's a lot of good research on like mixed ability grouping and the impact that can have in a positive way and so forth. I wonder to what degree though, does it really depend on the climate of the school and the degree to which those activities are like scaffolded and supervised? That would be sort of my initial take on it. Did you have any thoughts, Lily, or did anybody else have any thoughts about that?
I think your point about supervision is really important, just because I think peer tutoring could mean a lot of different things. And I think there could be a lot of different scenarios where like peer tutoring goes really well and it's, like both parties benefit and all of that. But I also think you could have scenarios where it doesn't go so well, or, the students get along really, really well, but no actual tutoring happens. Especially in a scenario where you don't have as much supervision. So I think there would be a lot of different considerations to make. And I think also tying it back to this, I think it would also depend on kind of why you're trying to do peer tutoring. Are you bringing peer tutoring in as a focus because you're trying to build the students' interpersonal competencies or whatever, or are you bringing it in because this is like a high school student tutoring a first or second grader, and like this high school student really understands this content area, things like that, so I think there would be a lot of different considerations, and I think there's a lot of different iterations that could affect it. Did anyone else have thoughts, concerns that they wanted to tie in here, or I could keep going? Okay, I'll keep going. So I definitely think that the potential implications of these results are numerous. It certainly raises the possibility of a potential omitted variable in previous non-cognitive research. However, I think it's important to emphasize that while these results could have implications regarding the inclusion of prior achievement in other non-cognitive research, it's important to consider the limitations of this particular study, and also to consider the very specific nature of this sample, including only students with SLD. So I certainly think that it would be valuable and appropriate to control for prior achievement in a wider range of non-cognitive research, but I don't necessarily think that this study alone can support the claim that prior achievement is an omitted variable in all previous non-cognitive research. Additionally, it raises the possibility that there may be differential effects for academic enablers and or academic self-concepts for students with SLD. In a paper by Elliott and colleagues, which was an analysis of patterns of academic enablers from the norm sample of their measure, the academic concept evaluation. I don't remember what the S stands for, but it's the ACEs measure. They found that
half the time either.
Yeah, I was like, oh, dang it. Jim would know. They found that the students with SLD exhibited higher levels of academic enablers than students who were identified as at risk for academic failure. So one possible explanation that they offered for this phenomenon was that students with SLD were identified as such because they were experiencing academic failure, even though they had exhibited these academic enabling behaviors. If that is true, then it may help to explain why the addition of the academic enablers did not add any significant additional explained variance to the initial models. So I wanted to ask what your thoughts are on the idea that students with SLD are identified because they're experiencing academic failure despite exhibiting these academic enabling behaviors. or other behaviors like that that might. So yeah, I just wanted to see what your thoughts were on that idea.
Were you going to share, BJ? Are you muted still?
Yeah, I think sometimes when we're identifying the students, it's because they have a lot of inconsistencies with SLD. You know, some day they're just right on, it just seems really easy. And the next day it's like they never saw it before. Where on some kids who just can't, don't seem to have it, it's just because they don't want to do it or they don't want to practice and learn the facts. These kids are trying to learn the facts, but they just seem new every time they look at them.
Yeah, and so teasing apart, you know, the idea of like can't do versus won't do, you know, and I think that, you know, I don't know what your all's experiences are in the field, but, you know, I think sometimes we have teachers who have sort of an intuitive sense of like when it's a can't do or a won't do, and they're able to kind of tease that apart just using their own, I don't know, sixth sense that they have going on. And then we have others that I think sometimes really get it screwy and get it backwards. And I wonder to what degree that can really have, you know, like a negative kind of an impact on kids in terms of, you know, making too many assumptions about can't do versus won't do. And if we make the assumption that it's a won't do when actually it's a can't do, what does that do over time to kids and so forth? It's challenging. And I don't know that there's any really easy answers for that all the time, but. And then when you throw into it too, the fact that we have so many kids who tend to have academic problems, who also have other problems too, you know, just working and playing well with others and other things. Sometimes it feels like, I don't know how often you all see this, but like sometimes it almost feels like you have kind of like a unicorn when you find a kid that, you know, they're able to really hold it together in all areas of school adjustment, but then they're just really tanking on the academics. Not that we don't see it, but it's, you know, not always as common. It can be tricky.
Yeah, I know. I'm always shocked when I like find a kid and it's like, oh, just like SLD in reading. That's the only thing you have going on, you know, like yeah. No attention struggles, no nothing else. Like, oh, interesting. Okay, well, I want to thank everyone for their attention. I do have a little bit more that I could talk about, but I want to be sure to address everyone's questions. So I'm happy to answer any questions that are here.
Well, actually, I have a question for the group.
Go for it.
Does anyone have any thoughts now in the context of RTI, how you think this picture could change, or are you not necessarily thinking that it would? I mean, I think the narrative around the triangle for so long has been that, you know, we're going to rule out all the teacher casualties. We're going to rule out all the motivation stuff with PBIS, and we're going to be able to really tease the stuff apart. And I wonder if that's what you guys are sort of seeing, or if you have a different perspective on whether the RTI process is helping with any of this in terms of, you know, how we identify and how we provide intervention. The only reason I say that in complete fairness, I'll just say this one other thing, is because one NASP conference, we had a person who came to our talk. We were talking about something completely unrelated to all this. We had so few folks that came in that we had asked, like, oh, so, you know, how come you chose this particular session versus the others? And she said, like, she got all like quiet and sheepish. And she said, honestly, it was the only presentation that didn't have the triangle. And I can't talk about it like anymore. Like, I cannot talk about the RTI triangle. So I was so excited that you didn't have the triangle that's why I had to come. And I'm like, honesty, I love it. Thank you. Part of the reason I bring that to your attention and wanted to ask you your thoughts. Okay, what's the rule on awkward silences? I think 10 seconds is adequate discomfort for everybody. Okay.
I know, I feel like that's like the hard thing about these virtual conferences. And I'm like, well, I can't like see half the people. So I don't know, like, are people like trying to work up their courage to talk, or are people just like waiting?
I guess I'll add something. I've been listening and just trying to find like the perfect time to speak, but I haven't identified SLD and math a whole lot in the 10 years that I've been working, but one of the things that we were always trying to tease out because of the new standards-based math curriculum and the procedural math that we're doing currently is in a district that's not really doing RTI is, you know, are the correct, you know, procedures being followed with making sure that a student has the study skills, knows how to choose a procedure, and hasn't maybe had enough practice on that, you know, before determining if they have a learning disability in math. I have noticed a lot of kids that I've evaluated that are also struggling in math are struggling in other areas too. And a lot of times there are attention issues at play. There are emotional issues at play. And so I've often found that link happening a lot more often with kids that are having issues in math. They're having it overall and not just in math than I have with evaluating kids and finding just simple single issues in reading. So that's often something that I try to tease out as well. I mean, recently I did work with a sixth grader who felt that her math skills were very poor, but in comparison to her reading, which was, you know, within like the high average to superior range, she felt that she couldn't do the math because it was just an area of weakness for her. And that I did see that, you know, getting in the way of her performance, because upon retesting, I did test the limits. I used cross battery assessment. I used the Wyatt with her first, and then I used the WJ, and I saw that upon reassessment, I had one test, you know, in applied math giving me, you know, low scores in her math. And then the next time I worked with her, she had average scores. And, you know, there was definitely a conversation that she had with me as a sixth grade girl, you know, being able to do that she doesn't feel like she's any good at math, you know. And so I did feel that with even in my 2 day in a row testing sessions with her, you know, a conversation about those strengths and weaknesses and everything boosted her her work ethic for doing the math, and she did do better on it. So to be honest with you, I think that this is still an area that probably needs to be looked at. But in regards to your statement, Cristin, I guess is it Cristin?
Yeah.
I do find that it's harder to tease this out because RTI is not necessarily focusing on math a lot. It's focusing on reading. And we have moved from, you know, standard algorithm procedures to, you know, putting things into a very complicated method for children. And they don't always want to just write down the steps to figure it out, you know. So I think a lot of it is you have to, you know, let them know that it's not going to come easily. It's not always going to be in your head. And you need to make sure that you are following the procedures that your teacher gave you and picking the strategy that works best for you. But, you know, putting it on paper sometimes, you know, makes a difference instead of just completely shying away from it and guessing and getting the wrong answer. So that's what I've noticed. And I don't know, Lily, if those are some things that, since this seems like an interest of yours, that you may want to look into a little bit further, or, you know, look into some research behind that.
Yeah, I definitely think some of the things that I heard you saying there were also reflected in some of the research that I've done that's looked at some of the gender effects related to math, which makes me sad. But, you know, and so I think that's also something that as we do move to strengthen our RTI math programs, I'm hoping that we can try to like build in better ways to address that. I don't really have an answer on how we can do that, but I hope someone does out there.
Like, math is also sort of weird. I mean, that sounds completely unacademic of me to say, but I'll just put that out there. So for example, I remember a kiddo who was being evaluated for gifted in math, and there was a discrepancy among like what was showing on like the WJ achievement, what was showing in other scores, and then the teacher's CBM. And the teacher's perspective was that this kiddo's math skills were much, but it was like over things like if he didn't understand what the little house was when you divide, like the old fashioned long division, he knew what the line with the 2 dots symbol was, but he didn't know what the house was. And so it wasn't that he couldn't divide the numbers, he just didn't know what the symbol meant. And so it's like, well, does that mean that he doesn't know how to divide? Like, I don't know that that means that you don't know how to divide. I think it means you don't understand what the symbol means, which is a different issue. Whereas with reading, it's a little cleaner than that. It's like you can read the words and you understand what they mean or you don't, but there isn't that same like other language system that's superimposed like it is in math. Mary, it sounds like you have seen that maybe.
Sorry, I was excitedly shaking my head because I thought I remember, and I could be misremembering this, but years ago that I went to a workshop on math, which talked about the fact that in the US, they see kids really tanking when reading and writing becomes more a part of doing math with word problems and that kind of thing. So I think to several people's point about it, it's got a lot of other skills involved. And I don't know if that's still the case, that there's this sort of notable drop off when it becomes more word and writing focused.
Right.
Well, I'm working with a second grader right now who on her assessment, I went and did a Pfeiffer assessment on math, and all these higher skills she can do, it's the lower skills she's struggling with. And we have on a little bit more investigation, it's her organization and her executive function that she's missing. Because even if I show her 2 pictures of the spot the differences, she can't visually pick them out. So we're starting to work on that. And I think if we can get those plugged in, all the harder things she's already figured out. She can look at something and tell me it's a fraction, but she doesn't really know how to add 10 plus 5 because she doesn't have her place value in line yet. But it's because of the rows in the columns.
Yeah, and then I've noticed, constructivist math curricula too. It's like if you can get the answer 2 + 2 is 4, but you can't write like the novel that you have to write or draw the pictures or the whatever. Sorry, I might be a little bitter because of now being in the land of helping my kids with new math, right? And I'm like, well, it's 4, right? And they're like, no, Mom, but you have to do like the things. And I'm like, can we just skip all this? That's me showing my age probably at this point, but I wonder, like, how does that play in? Like, can we say that we can identify SLD in math when the way that math work is scored at this point, depending on the curriculum, is dependent upon these other skills. And to me, it's like, is it really a math deficit when the kiddo just isn't going to write you a paper about how to make 10 or whatever, but they understand quantity? And so I don't know what the answer is to any of that too, but yeah, I think that's another thing that we'll probably have to grapple with over time in the math area.
Yeah, well, and that's, I think, a really interesting, some of what I'm hearing reminds me of one of the stats professors that I had last year talked about how there's, I think she said like 5 languages of statistics. You know, there's the numbers and the verbal, and then the visualizations, and I think she talked about, you know, like knowing the Greek versus the stuff. And honestly, I think there were like 2 others. I don't remember them all. So maybe I don't have them all down. But, you know, but I think even your traditional math, oh, maybe equations was one, you know, kind of has that same sort of like different languages, if you want to call it that. And I think that's where some of our students struggle is, you know, they have one part down really good, but they're struggling to remember the equations, or they're struggling to use the right words. You know, they can add the 2 numbers, but like, what's a dividend and what's a subtraction? You know, like, yeah, you know, like we use all this complex language, and it's like, if you just like showed them the numbers, they could do it. But like, and especially now with doing all these complex standardized tests so frequently, you know, we're relying on a lot of this more complex language a lot more, is what I'm hearing from students and teachers, at least. And so I think that is making it much more complicated than just like, you know, can the student do the addition problem? You know, it comes out to like, you know, can they describe how they got to the answer in the addition problem? So I think
I wonder too how this academic enablers idea and academic self-concept around, you know, like if it's not about the numbers, but it's about drawing the picture or writing the essay about the things and, you know, whatever, like at what point could that potentially over time become part of the roadblock in terms of the can't do, won't do problem? And might some of these variables kind of behave a little bit differently depending on the mode of instruction and, you know, depending on how math performance is being evaluated in terms of, is it from more of this, you know, constructivist kind of perspective, or is it more of a, like a old school explicit, whether you know your math facts, whether you can do the math operations, whether you can get the correct answer in terms of the right numbers versus the understanding of process and procedure and that sort of thing. So I think it'll be interesting to see over time how all that works itself out. So
yeah, well,
not as clean as, you know, you would think it could be potentially, but
yeah, well, and I was also going to mention, based on something that you had said, that like the authorization of No Child Left Behind and then ESSA in the intervening time since this was since the data was collected, and then, or at least since some of the data was collected, and then the vast increase in standardized testing in schools over the last 20 years or so has also likely had an impact on these variables that we're studying. And the other thing that I was going to say was some studies have also found that academic enablers are account for a higher percentage of the variance in student grades or like teacher assigned grades rather than standardized tests like the WJ. But the grades that I had access to in the data set just weren't really appropriate for the type of analysis that I was hoping to do. And so even though I knew that it would account for less of the variance, I chose to use the standardized tests. So that might be another study in the future, would be to look at the academic enablers and grades.
Does anybody else have any other questions or comments? Maybe time for caffeine and for people to stretch too. It's that time of day.
Yeah, I mean, I'm definitely happy to answer any questions you have or, you know, talk about whatever. But if people need a break, if people are tired, I know it's been a long day and a lot of people were up late last night. So.
Thank you so much. And I don't know if this was announced also, but for Act 48 credits, there will be a survey going out at some point. So check your emails. Okay, thank you, everybody. Thank you so much to Lily and to Dr. Hall.
Yep. Thank you for your attention.